Today we are going to discuss some important aspects of complexes and coordination compound. On the board I have given this question: matching. There are three columns. First column is the corresponding ionization. You know that complexes will exhibit different types of isomerisms. Second and third columns deal with the corresponding isomers for each isomerism. The isomers examples are given in column 2 and 3. Now let us consider, for example, first hydrate isomerism. In general it is also known as solvate isomerism, but if water as a ligand is involved, then we call it as the hydrate isomerism. Now you can look at column 2 and 3. Water molecule as a ligand should be involved. Now for example, consider the isomers given in column 2, and you can notice E involves water molecule as a ligand, CONH3 3 times Cl H2O twice, and Br2. So for hydrate isomerism I can choose from column 2 E CONH3 thrice Cl H2O twice Br2. That means in the case of hydrate isomerism there is exchange of ligands within the coordination sphere in capital E. Within the coordination sphere, water as a ligand is present. Now look at column 3 and see whether this water gets exchanged between the coordination sphere and the ionization sphere. And so if you look at column 3, A corresponds to the hydrate isomer. So for hydrate isomerism, 1 capital E from column 2 and small a from column 3. These three are matched. Similarly, look at 2 on column number 1, linkage isomerism. For linkage isomerism, you can notice there are ligands which can be coordinated in a particular complex through one atom and in the other isomer through another atom in the same ligand. For example, look at column 2. Consider G, Mn CO 5 times SCN. There are ligands which are known as ambidentate ligands. Ambidentate ligand means a ligand in which two atoms, not at the same time, either through, for example, in SCN, either through sulfur or through nitrogen, coordination is possible. G, through sulfur, coordination is possible. Now consider column 3. In column 3, you can notice Mn CO 5 times NCS. Through nitrogen, the coordination takes place. So in G of second column, through sulfur coordination, and whereas in the case of this small d in column 3, the same ligand, now it is coordinated through nitrogen. So in the case of ambidentate ligands, this sort of linkage isomerism is possible. Now consider third, ligand isomerism. Ligand isomerism, probably you remember, this involves some changes in the ligands. For example, if the ligand is a derivative of the phenyl group containing two substituents. If a benzene ring with two substituents means three isomers are possible, ortho, meta and para. If in one isomer the substituent is ortho and in the other it is para, and these involve ligand isomerism. Now look at column 2. For example, F, cobalt complex. In column 3 you can notice again B. I match 3 F and B. Now here Tn and Pn. Tn is nothing but 1,3-diaminopropane. Tn stands for 1,3-diaminopropane, whereas here Pn stands for 1,2-diaminopropane. Of course, whether it is 1,2 or 1,3-diaminopropane, these two in the ligand itself there is a difference. So for 3 F and small b, these are matched. Now come to optical isomerism. By the name optical isomerism itself, immediately you can come to the conclusion that optical isomers are in the form of enantiomers, dextro and levo isomers. So it is very easy. Look at column 2. B. This is small d represents dextro isomer. Naturally, there should be correspondingly a levo isomer. Column 3, you can notice G. Therefore, 4 B from column 2 and this G from column 3. These three are matched in the case of optical isomerism. Come to fifth one, ionization isomerism. It is quite obvious. In ionization isomerism, naturally the ions which are present within and without the coordination sphere, these are important. For example, you can consider column 2 and 3. Consider this C and F here. Now this thiocyanate ionizable, it is outside the coordination sphere. It goes inside and NO2 from coordination sphere comes outside. Therefore, for ionization isomerism 5 C F, 5 C F, these are matched. Now consider 6. 6 is polymerization isomerism. Polymerization isomerism means there is a simple formulae for a complex, and if you think of multiples of that simple formula, that involves this polymerization isomerism. Now you can refer to, say, A, CONH3 6 times COCl6. Now consider this one, CONH3 5 times Cl, COCl6 twice. Here 2 cobalt atoms are present and here 3. According to that, the number of NH3 and others will change, and so 3 times cobalt and all others accordingly they will vary. Come to 7, coordination isomerism. This coordination isomerism is involved in a particular compound in which both the cation and anion are complex ions. Please remember, in coordination isomerism, we find both the cation and anion are found to be complex ions. Now you can notice in column 2 and 3, those left out are D and here C. Now you can notice it is PTNH3 4 times here, and here it is CuNH3 4 times, here CuCl4 and PtCl4. That means if both the cation and anion, these are complex ions, then this involves coordination isomerism. So for the sake of completion, you please note down, I give the answer for matching 1 E A, 2 G D, 3 F B, 4 B G, 5 C F, 6 A E, and 7 D C. So as far as these isomerisms are concerned, the important isomerism we have included here and the corresponding isomers also. So for matching, I can choose, say for example, all these three, or I can have column 2 and